We started out trying to figure out why we want to use the robots. We have to select a solution, not the technology. We had a problem. We have someone that has a bachelor's in construction management that we're sending out to take a photo. Robots improve this process because it's repeatable, it's redundant. That's the key to it. And the more you do it, the better it gets. We started to be able to narrow down how we can use Spot and be able to not interfere with the workflow, because if you interfere with the workflow, now you've got a schedule change. So what is Spot? Spot is a quadruped. It's about 70 pounds, lots of battery, has a 90-minute runtime, and it does really cool stuff. Okay, and then what can we do? Can we make it autonomous so we don't have to be involved? What's the point of having a robot if you have to steer it all over the place? And then once we get it autonomous, how do we get it so we can add stuff to it and collect the data? If you can find a way to use it, most likely you can use it on Spot. So that's what we did. What makes it autonomous are these QR codes. They tie down corners of the map to a coordinate. We found out very quickly that site control was everything. Without the site control, we wouldn't be able to tie this down to the model, and the model couldn't tie down to what's actually happening in the field. Once we did that, then we can get into the DroneDeploy software and create these maps. Once we create that map, then we can do all kinds of cool stuff from it. We can start and stop a scan, we can start and stop a video walk, we can take a photo, anything that a superintendent would do, we can do in that mission. Sometimes you have to really just swing for the fences. We went from trying to figure out what to do to a sprint to see how much more we can do. So we crawled, we walked, and now we're running. My name is McKee. I work for Turner Construction. I'm a surveyor there, and I'm going to talk a little bit about how we use Spot in the real world. A lot of people think that Spot is one of those things that you use for HR or marketing or some kind of purpose that can't be used. So we started out trying to figure out why we want to use the robots. Because robots is a big thing, and the way the robot's going right now is it's increasing. Since 2020, it was a pretty good increase in the marketplace, and we wanted to be part of that. But why do we want to use robots? So robots is used in a lot of different kinds of industries. They're using in medical fields. They're using it in manufacturing, for automobiles, a lot of different things. But how do we use it in construction? And construction always seems to be the biggest question because it's a dynamic industry. There's a lot of things moving. So what we figured out is we need to know what the growth is so we can plan for this. In 2020, this is kind of when we did the study, and COVID was an outbreak, and everybody had to figure out how to work at home. And I even said that this is going to change the way that we do business. More Zooms, more online meetings, less people in the field working. So we start digging into it because the construction industry has, in some cases, has a lot of times finding trade partners, and the trade partners tend to do a lot of work. So if we get some of the robots in to take care of some of these mundane, repeatability type robot or tasks, and we can use that. So far, we're right on track. Some of the robots that we use currently, the overhead drilling, we've used that on our sites. Of course, the job site documentation with the drones, that's kind of why we're here. And then the bricklaying was a neat one to see, but some of the other ones we're still dabbling with. The layout is a good one too because you can lay out a lot of walls in a short amount of time or with less manpower. But some of the robot myths that we have. Now, this slide is different because we also partner up with DroneDeploy. And because of the work that we do with DroneDeploy, my partner that I rely heavily on for some of this, his name's Hayden Bradfield. He's not here right now, he's sick in the hotel as we speak. So I'm covering for him. But some of the robot myths that we have. So do they have a magic button to do all kinds of crazy stuff? Will they give you all the answers? Well, of course they do, right? Just check the internet. My robot has LiDAR, so I can make a point cloud. Robots will take our jobs. I hear that a lot. The robots will take my jobs. And most of the time it's no, we want to take you and move you to a different location so you can grow. So there is a workflow to all the robots, and those robots tend to benefit you if you can repeat that. There's a lot of automation to it, but you had to figure that out with the help from DroneDeploy. And with the scanning, everybody knows here that we also have, you have to process that and you have to manually compare that to something. And will they lose our jobs? Well, I mean, the way that I look at it is this industry is starting to become like a stock exchange. The stock exchange started out with a bunch of stockbrokers that would sell and trade stuff. Now we're at a point where the stock exchange is run by IT professionals, and that's kind of where we're at in the industry. So, with the partnership with DroneDeploy, we think as the robots as the horse. DroneDeploy is the cowboy because they can integrate just about anything, at least everything that we've thrown at them, and all those other little pieces and parts to it come into play. We use Spot. So what is Spot? We have a couple of them out here. There's Leica has one, and then I saw another yellow one that's out here, so I don't know who has that. But if you get a chance, you need to talk to some of these people because they're really good at it. So Spot is a quadruped, is what they say, and it's about 70 pounds, lots of battery, has a 90-minute runtime, and it does really cool stuff. It walks up and down stairs, and I hear that a lot to say, well, does it go up and down stairs? Yes, it does. It walks over all kinds of cool stuff, and the steps are really not a challenging part. What Spot is not the all-seeing eye. I mean, although you can get a web interface and you can see what's going on most of the times. It's not one of those where you can strap a gun onto it and, like RoboCop can do that. And it's not the Terminator. So don't be afraid of the Spot. Some of the spots that we have, well, there's one spot, but then you get the payload. So Spot's a vehicle like the horse. A lot of these things that we use, they work, some of them don't. The arm works, but we don't use it a whole lot. The inspection payloads that are in it, like the Cam Plus and the Cam IR, we don't use those at all because we're mostly just wanting to capture photos and scans. So a lot of stuff you don't use, but if you can find a way to use it, most likely you can use it on Spot. So what we did is we took Spot for a walk, and we started to see how can we use Spot, and we started out with like a process. You have to take the first step, or you have to crawl. You have to when you go from crawling, you have to walk, and then from walking, you have to run. So we're in a phase 1, phase 2, phase 3 type thing. So we needed to check and see if it had mobility to it. And if it had the mobility, okay, and then what can we do? Can we make it autonomous so we don't have to be involved? What's the point of having a robot if you have to steer it all over the place? It's kind of like a tripod on legs. And then once we get it autonomous, how do we get it so where we can add stuff to it and collect the data? So again, crawl, run, and walk. So that's what we did. That's what we started with. But the things we didn't test, well, we might have tested it like this just a little bit because, we're curious and we want to see if it can hold up if someone knocks it over. And it was kind of fun. So the first part of the mobilities is what can we do something simple? Walking over the pallet, having to walk over some wood, simple things like that. Worked pretty well. So we thought, okay, let's step it up a notch. Let's see about the rebar on the metal deck. Worked pretty good on that too. We actually had some people that were like, is it really good to walk across that? Yes, it's really good to walk across that. And if you look at it, if you look at the feet are actually being placed in a position. It's not like it's sliding down that corrugated part. So that worked pretty well. This is where the challenge was. It was the mobility. If it's loose, it has a hard time keeping balance, but it works pretty well. So we found out pretty quick that, okay, let's try to make it more stable. Let's keep it on the concrete. Some of the little challenges that we didn't think was the problem was the water. Because of the sensors that are on the robot, the water tend to reflect back its sensors. So what we had was this dance. They call it a drunk robot, kind of looks like that. And it was really strange. So that was a challenge for us because, before you dry in a building, you're gonna have water everywhere. I mean, it's just crazy. So that was some of the other challenge. But we did have some stumbles. So walking up and down the steps tend to cause problems. These are the homemade. These are made to go up and down ditches and things like that. And you notice that it couldn't go up the steps. And we're doing this on purpose because we want to see what it can handle. Now, the guys from Boston Dynamics were kind of not great on it, but we still did it. This was fun. It was like, the big giant, yeah. So we found out what it can't do. So we narrowed down that mobility. Then we got into the autonomy side of it. Like, okay, how can we really make this autonomous? Now, what makes it autonomous are these QR codes. They're fiducials. Aerial fiducials, work the same way. They tie down corners of the map to a coordinate. We're doing the same thing with these fiducials. We're tying down a map to a location, and it looks at those locations and comes by and says, hey, this is where I'm at. Once you do that, then you start to incorporate some walking to that. Now, this was on a site that we did, and the wall was put there after the mission was made. So, did it recognize it? Okay, big check mark. It did. We're good with that. But what really made a difference was the dock. Now, what the dock did was a starting point. We create a starting point in our mission that it starts and comes back on. And once it does that, then now we're good to go. So it was those little things. Again, it was the horse, and all the other platforms was stuff that we're adding to it. So this is where we really had to dig in. Now, with the help from DroneDeploy, and I say that lightly, it was a turning point for us. When we got DroneDeploy involved with this, we went from trying to figure out what to do to we're on a sprint to see how much more we can do. We found out very quickly, just like as the panel that was up here, that site control was everything. Now, I've been surveying for 30 years, so I know that everything is tied down to planet Earth. So we knew that we had to have the site control. Without the site control, we wouldn't be able to tie this down to the model, and the model couldn't tie down to what's actually happening in the fields. So that was important. Once we did that, we got these geospatial relationships to that by tying all that stuff down, setting the control points down, tying the fiducials to the control points, and then tying all the map to that. Once we did that, then we can get into the DroneDeploy software and create these maps. And what you're doing, you're basically just walking spot and letting it record where it's going. It's a whole bunch of these little lines that puts together, makes a trajectory, and that's what creates the map. Once we create that map, then we can do all kinds of cool stuff from it. We can start and stop a scan. We can start and stop a video walk. We can take a photo. We can, anything that a superintendent would do, we can do in that mission. So then we take those tasks or those missions and we try to break it down to the autonomous data handling. Like, okay, I can go out with a photo or I can go out with a camera on a unicorn mount and take a photo and tie that to a spot in the drawing with instruction site or open space or anything else that you want to do. Now, how do we do that without actually doing the task? We can do it autonomously. That's where DroneDeploy came into play. Once DroneDeploy came into play, then we were able to upload autonomously those photos, place them on a map and we use Struction Site, and then upload the scans, post them into a server to where we can download them and process them. We still have to do that because you got to be able to take the scan and tie that down to the coordinates on the site, which ties to the building. So once all that's done, now you're good, and you repeat that process on every project that you go to, on every mission that you go to. Works pretty well. This is our site. So all those yellow lines that you're on there, that's the map. What we basically did after creating the map is you create a polygon around the area that you want. Once you create that polygon, then you execute spot, and you walk spot through that polygon. It uses the map as a path and then just walks. Once you get that, then that gets uploaded into Struction Site, and you get that kind of video like that. These were intended walks. It was like we wanted it to go to these specific locations. We wanted it to go down this hallway. We wanted to go in these rooms. And instead of going in and placing points in each one of these rooms after the map, we just draw the polygon, and then it walks. So works pretty good. That's the interface. So we have to select a solution, not the technology. We had a problem. We had a problem saying that, okay, we don't have anybody here that can do this. Or we have someone that has a bachelor's in construction management we're sending out to take a photo. If you were fresh out of school, and I know some interns are like, well, yeah, that's what we have to do. So everybody after us has to do that. It doesn't really work, I guess. I don't know. So find the solution. Well, this was a good solution. Robots improve this process because it's repeatable, it's redundant. It's the same thing over and over again. If you have to be, and I've had some people say, okay, well, I want to send Spot out to do this, and it's just one thing. Well, it's not going to really work that well. You're going to have to probably do it manually, and if you're going to do that, you might as well just take Spot or take the camera and do it yourself. So that's the key to it, is something that's redundant, something you're going to do over and over again, something that you're going to repeat that process. And it has to be simple. So increase the technology maturity decreases that complexity. And the more you do it, the better it gets. And the more you do it, the more problems that you find to resolve those problems to make sure that you are doing it right the next time. We worked hard at this. This was a 3-year process, lots of trial and error, lots of trying to figure out how to get it until we found that one piece of the puzzle, which was DroneDeploy, to be able to set us on place. Once we did that, it was wide open. Now we're taking it places. It's sitting on sites right now and collecting all of that lovely dust that gets turned up through the process, so I had to clean it. But it's working. So I've had some discussions with some of the people that have been here. The innovation technology trajectory is kind of standard, where like an iPhone, you see that technology and you buy it and you're good for it, and then the performance of it, you get used to it. Well, we've got this hyper cycle of emerging technologies. I think this is a best way to describe it. And I've talked to even some people about this. You have this innovation trigger that sends you through the roof. Oh, this is something we have to have. We have to get this. And you go to your boss and you go to everybody else and you go, you know what? We got to have this. And they're like, okay, great. What are you going to do with it? Yeah, I don't know, but we have to have it. So you got this peak of inflated expectations, like, well, we can do all this grand stuff with it. We can save time and money, and then it drops because you can't figure out how to insert that piece into a workflow. So that trough of disillusionment is, we were there, and it sucks. There was a lot of struggle. We worked with a couple different companies, and it was just like you're banging your head against the wall. But then all of a sudden, this slope of enlightenment came up. We started to understand things. We started to see how things were moving. We started to be able to narrow down how we can use Spot and be able to not interfere with the workflow, because if you interfere with the workflow, now you've got a schedule change, and you can't do that. So once we figured all that out, then we were on this plateau of productivity, which is where we're at now, and we're just sailing along. I mean, there's little things along the way, but some of the maps get really big, but other than that, it works out really well. And it still comes down to you're solving your problem. So it comes back to the same scientific method. What do you have to do? You have to do that same process. Map out your process, and you got to test everything. And there was a couple other people here today were talking about testing things that you fail, and then you're constantly reinventing that. And it was a failure thing, and until we figured out what we needed, figured out how we can use all that. And then once you do that, then you need to test it more. Like, okay, I got it down, I need to test it more. So a broken process with new technology is still a broken process. It doesn't matter what it is, it'll still be broke. So we crawled, we walked, and now we're running. And it works pretty well. But sometimes you have to really just swing for the fences and being able to say, okay, I have to really do this. This is something that needs to be done. You have to buckle down and just force it through. Once you do that, you can kind of step back a little bit and analyze things, but that opens things up for different improvements, different robots. The layout robot, the humanoid robot that Boston Dynamics have. So we're still trying to figure that out, but so far we've got one check off our list, and it works pretty well. And this was quoted too: the best way to predict the future is to create it. So I encourage, if anybody sees me out and about, come up and talk. I love talking about this. I really enjoy talking to people and trying to find good solutions. But other than that, that's all I got. So thanks.